So my presentation is on Hadoop. So what is Hadoop? Hadoop is considered an open source set of tools, and basically you can distribute it with the Apache license, which means that there'll be no company that can control the flow of your Hadoop. And basically Hadoop will support any application of big data. And this is where my presentation will lean towards, big data. So Hadoop will have a framework of tools which you can run application for big data. Now, in terms of big data, what exactly is big data, right? So big data is considered an extremely large set of data that could be analyzed to reveal maybe patterns, trends, association, in terms of human behavior, right, and interactions with this data. So in terms of big data, nowadays there's a lot of issues that you face with big data, and here are the three main issues with big data that most big companies face. I'll use an example as Facebook throughout to show you what I mean. So the first thing is data is coming in way too fast, right? Meaning that there's so much data coming in at once, it's hard to interpret all that data. In terms of Facebook, if you look at how many users they have, right? They have millions and millions of users, and they do a lot of things on Facebook, maybe click on pages, try new things on Facebook, maybe like or share something. Facebook would maybe want to keep track of all that data to see the trends and patterns that people follow to better help their company, obviously. So that's one of the issues that they could face, that the data is coming way too fast, it's hard to handle. The second thing is the volume of data. In terms of Facebook, they already have so many users. Users keep getting, they probably get new users on a daily basis, right? So the amount of people that use Facebook is going to keep going and growing. In terms of that, the volume of data is just going to keep growing and growing. And in terms of that, it's hard to keep track of all that data if it's going to keep on growing. So what can we do to do that? The third thing is the variety of data, right? There could be many different types of data. There's, for example, audio data, video, log files, and it's hard to keep track of all this data when there's many different types of data. So that's another issue they face. I call these the 3 V's: velocity, volume, and variety. These are the things they face. In terms of the traditional method, the original method was that you would take all this big data and you would process it through a very, very powerful computer. As you look at the image below or above, the data is being processed through a powerful computer. But what happens when that data is too big, right? Because one computer obviously has this processing limits. So all that data is hard to get analyzed if there's a limit to process the data. So that's one of the issues with the traditional method, that even though maybe it'll crunch down the numbers and give you the results, it can only do that until the computer can no longer could handle the amount of data that there is. So the Hadoop method with big data is the fact that it'll take all this big data and break it down to smaller pieces. And it's a very different approach than the traditional method, because from this approach, it'll take the data, break it down. For example, if you look at here, 3 pieces, right? It'll break it down, and then it'll compute whatever needs to be computed with that data. It'll pass it down again. When it's passed down, it'll again compute whatever data was collected after passed down and give you the results. I'll give you an example. Let's say that we had a lot of big data in terms of the amount of rainfall that fell in the past 12 years, right, on a day-to-day basis. That's a lot of data to interpret, and we wanted to find out the average rainfall in the past 12 years. So in terms of that, it would break it down to 4 years a piece, right, for each data. It'll compute the average for those 4 years, the amount of rainfall, the average rainfall. After it gets the average, it'll pass it down again. Now we have 3 data files, which each has its the amount of rainfall fell in 4 years. And again, it'll compute the results. And that's basically the benefit of Hadoop method, right? It breaks down the data and then computes it a piece at a time. In terms of the traditional method, it was only able to do it on one computer. This could do it on plenty of computers and analyze that data on different computers, which makes it a lot better, which means there'll be less worry. And that's one of the benefits of Hadoop. They want their clients to feel less worry about their data. In terms of less worry, what I mean is that you won't have to worry about the file location, because there's a master node that takes care of keeping track of where the file is located. It also manages the failures. So you don't have to worry about keeping in check about if data was lost or whatsoever. And obviously it'll break down the computations to pieces for you. You won't have to do that at all. That's what Hadoop will do for you. And then at the end, the biggest thing is that it'll be able to do scale-free programming, meaning that Hadoop takes care of scaling. So if you were to write a program for 1 megabyte file, you'd be also able to run that same exact program for a 100 gigabyte file as well. And that's why there's really no limitations to the amount of data. Because in terms of if you look at linked lists or arrays, you can set a limit to how many elements you can store, right? But once you reach that limit, you can't do much. You have to change the limit again. And that's one of the benefits of this, right? There's scale-free programming. And that's what programmers want. They want to be able to write scale-free programming and don't have to worry about that. In terms of what is actually happening behind Hadoop, right? What is some of its features? The two main components it has is MapReduce, which is the data processing unit, and then something called the HDFS, which is the file system. In terms of MapReduce, I'll give you an example of where it's at work. It'll be one of my demo programs. So before I get into that, let me explain to you what exactly it is. So MapReduce is obviously the most efficient and performant method out there. It's so special in the fact that it'll process the data where the data is located. So you won't have to move the data around, which is obviously a benefit. So the MapReduce program has two components. The map function, which basically will perform the filtering and sorting. And for example, it might sort the students by first name maybe into a quants and then one quants for each name. And then there's a reduce function which is a procedure that performs a summary of the operations, such as maybe counting the number of students, right? And yielding maybe some value or frequency. And then the benefit is that Hadoop will take care of all the small details. So while you're running all this, you won't have to worry about failures like issue tasks, verifying tasks, and copying data. So I'm going to go ahead and run a demo for you. So I'm going to run this from right here. So if you look right here, right, I already have the query written out. And if you look on the side right here, it's very, very similar to stuff we've been doing in class. We have our table right here with its values or whatsoever. We have the ID, which is all the different individuals. And then obviously we have the values and numbers and frequencies and whatsoever. And then we have this 2007 file. This is going to be my sample file I'm using. And basically I'm going to be analyzing data from the year 2007, where in this year it collected the amount of the salary that people make in terms of all the different occupations there are. So we have two different files in the 2007 file. We have we have the description, which is the different occupations, and we also have salary, which is the amount of money they obviously make. So really simple query. If you look at right here, obviously we're going to select from the sample file the description and the salary, and we're going to get that from the sample 2007 file. And we're going to set the limit to all the salaries that are greater than 100,000. So here I'll show you an example of what the explanation of how MapReduce will actually work. So right here we have our MapReduce function, and we have it broken down. We have the map and the reduce. So map up here is it'll perform the filtering and the sorting. So in terms of it'll analyze all the data and it'll sort it according to the occupation. And after that, it'll start going and looking to the salary, and it'll reduce the procedure, and such as obviously in this room counting this occupations and the salary. So that's what reduce will do. So as you can see, it's broken down into two components, map and reduce. And if I go ahead and execute, hopefully this works. It might take a while. Okay, it's a log file. Let's go to results. I'm running this off of free software you can get from Cloudera. You do not need a cluster. They give you a free demo program you can use, and that's what I'm using. So results, you'll just see it's a lot of data, and you'll see just how quickly it does it. Obviously, in terms of I'm using a cluster that already came with it. So in terms of just using one computer, this may take a long time. but all right, here we go. So if we look, we have our description, which is all the different occupations there are, right? And then we have on the right side over here the salary and the average salary for that occupation. So in terms of the file, you can see that how big of a file this was and how it broke down all the values. And you can see we have whatever up to the top 27 or so. And this is one of the benefits of big data. So I hope you like the presentation. Hadoop, it's a great method to use in terms of big data, and there's also Oracle SQL you can use for big data as well.